The Voice of America presents Forum, the Arts and Sciences in Mid-Century America. Today, Forum brings you the 9th lecture in the Philosophy of Science series, planned and coordinated by Professor Sidney Morgenbesser of Columbia University. Today's lecturer, Norwood Russell Hanson, is a distinguished scholar of philosophy of science. He received his Bachelor of Arts degree from the University of Chicago in philosophy and logic. He then obtained a Bachelor of Science degree in physics and a Master of Arts degree in philosophy from Columbia University. Professor Hanson holds a doctorate from both Oxford University and Cambridge University. He has received, among many honors, a Fulbright Scholarship and Fellowship, a Ford Foundation Fellowship, and a Rockefeller Fellowship. He has lectured at Cambridge and Oxford Universities and has been Professor of Philosophy at Indiana University since 1957, serving as Chairman of the Department of History and Logic of Science since 1960. In September, he will join the faculty of Yale University. Professor Hanson will speak on observation and interpretation. Professor Hanson.
Philosophers often conjoin the terms observation and interpretation. They go together, like peaches and cream, ham and eggs, or fish and chips. But familiar conjunctions like these latter differ from observation and interpretation. We can speak of peaches before the cream has been poured. Ham can be had without eggs. Fish are distinct from chips. However, what is an observation before it is interpreted? What could interpretation-independent observations be like? Are the two separable at all? I contend that observation and interpretation are inseparable, not just in that they never do occur independently, but rather in that it is inconceivable that either could obtain in total isolation from the other. Models more suitable than peaches and cream and ham and eggs would be pairs like warp and woof, lift and drag, indeed matter and form. There might be arguments for conceptually separating the warp from the woof in a fabric, the lift from the drag on an airfoil, and the matter from the form of a statue. Nonetheless, argument is required. I place observation and interpretation into the same category of conceptual pairs. Just as separating the warp from the woof destroys the fabric, and separating the lift from the drag on a wing will render aircraft unflyable, and just as separating matter from form in a statue describes nothing operationally intelligible at all, so also slicing the incoming signals of sensation from appreciating the significance of those signals would destroy what we know as scientific observation. The neo-positivistic model of observation, wherein our sensational data registration and our intellectual constructions thereupon are cleft to twain, this is an analytical stroke tantamount to logical butchery. It results only in the failure of the heart of natural science, whose very pulse is the struggle towards more intelligently encountered, reasonably comprehended, and theoretically appreciated observations. Many philosophers will, even here, have lost sympathy with me. Their analyses concern the data of scientific observation, its cash value. Where do people err in reporting their observations? Usually, just in exaggerating their descriptions of what they encountered, not in their having received the wrong sense signals from the outer world. Folks will speak of seeing water in that flask, when actually wood decomposes if floated in it. In fact, it's a weak acid. Or they'll speak of seeing ice, although it won't float on ordinary water. It's frozen deuterium, in fact. They'll speak of looking through ordinary glass, not realizing that when turned 90 degrees, it becomes opaque, it being actually Polaroid. So these descriptions of observations were in error, not because the observer's sense organs failed to pick up signals impinging on them. Rather, the errors arose because of jumping beyond the pure observations to speculations by far surpassing what the basic data warrants. If only observers would restrict themselves to the color patches they see, the buzzes and tinkles they hear, the rough and smooth surfaces they touch, and the sweet and sour tastes of things, only then could the strictly empirical basis of an observation be detached from the theoretical embroidery attached thereto. Only then can the properties of nature be demarcated from the properties the observer's theories consist in about nature. Of course, such a positivistic recommendation is compatible with the recognition that, within contemporary science, what are called observations are really intricate mixtures of empirical components and theoretical frosting. What is called scientific observation is apparently genuine observation to but a very small degree. So runs the recommendation. Unless we remain alert to this, our philosophies of science may issue with the apparently absurd suggestion that two reliable observers could encounter the same physical phenomenon and yet register different observations. But if two well-made cameras were aimed at the same phenomenon, they would take the same picture, and two tape recorders would record the same noises if similarly placed with respect to an acoustical source. Similarly, continues the recommendation, two ideal scientific observers should make the same observations. What they then proceed to make of those observations is another matter, concerning which philosophers have also said very much. But two observers, especially when their theoretical commitments differ, can make the same observations only insofar as their encounters with phenomena are described strictly in phenomenalistic or sense-datum terms. Differences between them are manifested only after taking in the data. So the positivist's motto is, first observe, then theorize. In the interests of more realistic philosophy of science, however, I will press for the opposite conclusion. I will even argue for what seems so absurd to the phenomenalist, that two observers, equally well equipped, may confront the same phenomena and yet make quite different observations. This not because they are busily clamping different theories onto the otherwise pure data, but rather because they are observing. To observe X is to observe X as something or other. That will be our motto. Observing is an experience. A retinal reaction, or an olfactory or tactile reaction, is only a physical state, a photochemical or pressure-sensitive excitation. Physiologists have not always distinguished experiences and physical states. People see, not their eyes. Cameras and eyeballs are blind. Attempts to locate within the organs of sight, or within the neurological reticulum behind the eyes, some nameable called seeing or observing, may be dismissed summarily. There is more to seeing than meets the eyeball, and there is more to scientific observation than merely standing alert with sense organs at the ready. Consider the Necker cube, so familiar to psychologists. On the page before you, 12 connected lines seem configured in the standard box-like way. Do we all see the same thing? Some will see an ice cube viewed from below. Others will see it from above. Still others will view the figure as a polygonally cut gem. Some see only crisscrossed lines in a plane. Others will see it as an aquarium, a wire frame for a kite, or any of a number of things. Do we then all see the same thing? And if we do, how can these differences be explained? Well, here the phenomenalist's formula re-enters. Quote, "These are different interpretations of what all normal observers see in common." Close quote. Retinal reactions to a Necker cube are virtually identical. So too with our visual sense data, since our drawings, for example on grid paper, of what we see will have the same content. They may even be congruent. The drawn Necker cube is simply observed now as a box from below, now as a cube from above. One does not first soak up an optical pattern and then clamp an interpretation onto it. But, comes the phenomenalistic retort, seeing a Necker cube first as a box from below and then as a cube from above involves interpreting the lines differently in each case. Close quote. Then, for two observers to have a different interpretation of a Necker cube just is for them to observe something different. This need not mean that they see exactly the same thing and then interpret it differently. Besides, the word interpretation is occasionally useful as we now employ it. We know where it applies and where it does not. Thucydides presented the facts objectively. Herodotus put an interpretation on them. The word does not apply to everything, that is, it has a meaning. Can interpreting always be going on when we observe things? Sometimes, perhaps, as when the hazy outline of a combine harvester looms up before us on a foggy morning, and, with some effort, we finally identify it. Is this the interpretation which is active when bicycles and boxes are clearly observed? Is it active when the Necker cube snaps into its other perspective? There was a time when Herodotus was half through with his interpretation of the Greco-Persian Wars. Could there be a time when one is half through interpreting a Necker cube as a box from above, or as anything else? Quote, "But the interpretation takes very little time. It is instantaneous." Close quote. Instantaneous interpretation hails from the same limbo that produced unsensed sensibilia, unconscious inference, incorrigible statements, and negative facts. These are notions philosophers force on the world to preserve some pet epistemological or metaphysical theory. Only in contrast to eureka situations, like perspective reversals where one has not even time to interpret the data, only in contrast to these is it clear what is meant by saying that although Thucydides could have put an interpretation on history, he did not. Whether an historian is advancing an interpretation or not is an empirical question. We know what would count as evidence one way or the other. But whether we are employing an interpretation when we see a Necker cube in a certain way, this seems not to be empirical. What could count as evidence? In no ordinary sense of interpret do I interpret the Necker cube differently when its perspective reverses for me. And if there is some extraordinary sense of the word, it is not clear, in ordinary language or in philosophical language. To insist that different reactions to the Necker cube must lie in the interpretations put on some common visual experience is just to reiterate, but without reasons, that observing of X must be no more than the same sensation registration for all observers looking at X. But it will be countered. I see the figure as a box means I am having the visual experience I always have when I interpret the figure as a box or when I look at a box. Close quote. Now really, if I meant this, I ought to know it directly. I ought to be able to refer to that experience directly and not only by indirect references to boxes. This counter typifies what is meant by calling sense data logical destructions out of material objects. Everyday accounts of the experiences appropriate to viewing a Necker cube do not require visual grist going into an intellectual mill. Theories and interpretations are there in the observing from the outset. Consider further all those reversible perspective figures which appear in textbooks on Gestalt psychology, the tea tray, the shifting staircase, the tunnel. Each of these can be seen as concave, convex, or as flat. Do I observe something different each time, or do I only interpret what I see in a different way? To interpret is to think, to do something a la Herodotus. Observing is the having of an experience. The different ways in which these Gestalt figures are seen are not due to different thoughts lying behind the visual reactions. What could spontaneous mean if such reactions as these are not spontaneous? One does not think of anything special, one may not think at all, nor does one interpret. One just observes, now a staircase as from above, and now a staircase as from below. There is a range of other variable figures, those called variable aspect figures. The most famous is Köhler's Goblet and Faces. One can see a Venetian glass centered against a dark background, or two profiles facing each other. Again, we take the same retinal, cortical, sense datum picture of the configuration. Our drawings on grid paper might be indistinguishable. Yet I see an ornate goblet, and you see two men staring at one another. Do we see the same thing? Yes, in some elementary sense. Do we observe the same thing? Perhaps not. I draw my goblet, but you say, "That's just what I saw, two men in a staring contest." Now what must be done to get you to see what I see? When attention shifts from the cup to the faces, does one's visual picture change? How? What is it that changes? What could change? Nothing optical or sensational is modified, yet one observes different things. The organization of what one observes has changed. Imagine now a glass and metal instrument replete with wires, reflectors, screws, clamps, and push buttons. Imagine this instrument placed before a trained physicist, one who at that moment is holding his 2-month-old infant on his knee. Do the physicist and the infant observe the same thing when looking at such an X-ray tube? Yes and no. Yes, they are visually aware of the same object. No, the ways in which they are aware are profoundly different. Seeing is not only the having of a visual experience, it is also the way in which the experience is had. This does not mean that the physicist is busy with intracranial activities absent in the child's case. This may or may not be so. Both simply see what is before them. The physicist sees a glass and metal instrument. His child takes in precisely the same optical data, but may be observing nothing in particular. In college, the physicist had gazed at this instrument each day. Returning now, after years in industry and research, his eye lights upon the same object. Does he see the same thing as he did then? Now he observes the instrument in terms of electrical circuit theory, thermodynamic theory, the theories of metal and glass structure, thermionic emission, optical transmission, refraction, diffraction, atomic theory, quantum theory, special relativity, and the problems of atomic energy and nuclear machines. Quote, "Granted, one learns these things, but it all figures in the interpretation the physicist puts on what he sees. Though the layman sees exactly what the physicist sees, he cannot interpret it in the same way because he has not learned so much." Close quote. But is the physicist doing any more than just seeing? No. He does nothing over and above what the layman does, what he himself did as a young student, or what his child does when he sees an X-ray tube. What are you doing at this moment over and above listening to these words? Are you interpreting sounds on the airways, Would this ever be a natural way of speaking? Perhaps, if English were not your native language, which makes the same point in reverse. Would an infant hear what you are now hearing when you hear words and sentences, and he hears but noises and sounds? One does nothing beyond looking and seeing when he dodges automobiles, glances at a friend, or notices a cat in the garden. Quote, "The physicist and the layman see the same thing," it may be objected, "but they do not make the same thing of it." Close quote. Well, the layman can make nothing of it. The child can make nothing of it, nor is that just a figure of speech. I can make nothing of the Arab word for ice cube, though my purely auditory impressions may be indistinguishable from those of the Arab, who hears his word for ice cube quite clearly. I must learn Arabic before I can hear what he hears. The layman must learn some physics before he can observe what the physicist observes. As the great astronomer William Herschel observed, quote, "Seeing is an art which must be learnt." Our motto now, then, is first learn, then observe. The creature that has learned nothing can observe nothing, and that's part of the semantical content of the word observe. The visitor must learn physics before he can observe what the physicist observes. Only then will the context throw into relief those features in the phenomena which the physicist observes as indicating resistance. This obtains in all cases of observation. It is all interest-directed and context-dependent. Attention is rarely directed to the space between the leaves of a tree. Still, consider what was involved in Robinson Crusoe seeing a vacant space in the sand as a footprint. Our attention naturally rests on objects and events which, because of our selective interests, dominate the visual field. What a blooming, buzzing, undifferentiated confusion visual life would be if we all arose tomorrow morning with our attention capable of dwelling only on what had heretofore been completely overlooked. Indeed, our mental institutions are full of poor souls who, despite having normal vision, can observe nothing. Theirs is a rhapsodic, kaleidoscopic, senseless barrage of sense signals, answering to nothing. The physicist baby and the layman laboratory visitor, they can see all right, they are not blind. But they cannot see what the physicist sees. They are blind to what he sees. Their eyes are normal, but they cannot observe what he observes. We may not hear that the oboe is out of tune, though this will be painfully obvious to the trained musician. An Arab pronunciation of cat may clearly indicate a northern dialect to a native. It may be a completely unintelligible noise to us. Incidentally, the musician does not hear the raw tones of the oboe and then interpret them as being out of tune. He simply hears the oboe to be out of tune. The Arab simply hears the word as indicative of a northern dialect. We simply see what time it is. We don't visually remark the position of the clock hands and then clamp horological interpretations onto the sensations. The surgeon simply observes the wound to be septic. The physicist simply observes the X-ray tube's anode to be overheating. The elements of the laboratory visitor's visual field, though singly and severally identical with those of the physicist, are not organized for him as they are for the physicist. The lines, colors, and shapes are apprehended by both, but not in the same way. There are indefinitely many ways in which a constellation of lines, shapes, and patches may be seen. Why a visual pattern is seen differently is a question for experimental psychology. But that it may be seen differently is important for any examination of the concepts of observation and interpretation. Only by an examination such as we have just been through is it possible realistically to understand how two different scientific observers can encounter the same data, commit themselves to the same descriptive statements, and yet draw diametrically opposed conclusions as to the significance of what they encountered. This long before the explicit theorizing begins. The issue is still, what are the data? The simple phenomenalistic formula suggests that they took in identical data and then clamped well-developed but different theories onto them. But surely it might be argued that, since their total accounts of what they observed were so radically different, there must be a sense in which they did not begin from the same observational data at all. Remember, the Necker cube was not the invention of a mischievous psychologist. It dates from 1832, when the Swiss naturalist Necker described how certain rhomboidal crystals could be microscopically viewed obliquely, such that their perspective could shift in the now familiar way. One need not work overtime to invent variable perspective and variable aspect figures to establish that observation and interpretation are inextricably intertwined. Such phenomena are to be found daily in the research work of observational microbiologists, X-ray crystallographers, bubble chamber physicists, and so forth. A meaningful scientific observation must be of something as something of some kind. This requires appreciation of the data beyond anything a camera or an eyeball is capable of. It requires, indeed, a scientific observer. Again, one cannot, in principle, heighten the lift on an aircraft wing without generating an induced drag, which is but another aspect of that very airflow that produces the lift. Interrupt that flow to separate the drag from the lift, and you destroy the lift altogether. The matter and the form of a statue are inseparably intertwined, a point which Aristotle commended to our attention over 2 millennia ago. By reflections of the same kind, observation and interpretation must be seen as inextricably intertwined. Within natural science, one can, of course, distinguish those cases of observation wherein theoretical extrapolation dominates the empirical base from other cases within which the data appear to dominate. But one cannot, in logical principle, go to the limit of considering scientific observation as totally unformed by significance criteria, or, on the other hand, scientific theories as completely separated from questions of what actually happens. Hence, scientific observation and scientific interpretation need neither be joined nor separated. They are never apart, so they need not be joined. They cannot in principle be separated, and it is conceptually idle to make the attempt. Observation and interpretation are related symbiotically, such that each conceptually sustains the other, while separation kills both. This will not be news to any practicing scientist, but it may seem heretical indeed to philosophers of science for whom analysis has become indistinguishable from division.
You have heard Professor Norwood Hanson of Indiana University speak on observation and interpretation. Next week, Professor Hilary Putnam of the Massachusetts Institute of Technology will speak on probability and confirmation. Copies of the Philosophy of Science series may be obtained by writing to the Forum Editor, Voice of America, Washington, D.C. This is Morris Joyce, inviting you to join us again next week at this time for Forum, the Arts and Sciences in Mid-Century America.